I want to discuss an application of weighted average related to the chair example you saw at the beginning of this section. The weighted average we're going to talk about is called center of mass. What is center of mass? Consider a thin rod, like a meter stick, made of a uniform material. Then you expect that if you place your finger at the very center of the meter stick, it will balance. This point where it will balance is called the center of mass. But what happens if the rod does not have uniform density? Suppose the first half of the meter stick has a linear density of 2 grams per meter, and the second half has a linear density of 20 grams per meter. So the first half is made of something very light, and the second half is made of something very heavy. Now where's the balance point, or the center of mass? It's not going to be in the middle. You'd expect the center of mass to be somewhere in the middle of this very heavy portion of the rod, but just a bit to the left of that midpoint, since the lighter part will have some mass. The center of mass, x bar, is defined as the weighted average of the position x along the rod weighted by the linear mass density, lambda x, which in this case is 2 grams per meter for 0 less than or equal to x less than 1/2, and is equal to 20 grams per meter for 1/2 less than x less than or equal to 1. Let's go ahead and compute the center of mass. This is the ratio of the integral from 0 to 1 of x times lambda x dx over the integral from 0 to 1 of lambda x dx. Notice that the only difference between the numerator and the denominator is this factor of x here. Before we calculate this, let's note that the units make sense here. X has units of meters, lambda has units of grams per meter, and dx has units of meters. So the numerator has units of grams times meters. The denominator is the integral of lambda with respect to dx, which is just adding up all of the mass density along the rod to get the total mass. So this integral has units of grams per meters times meters, which is units of grams. When we divide these two integrals, the resulting weighted average has units of meters, which are the units we expect a position to have. Let's finish this computation by expanding out these integrals. The numerator is equal to the integral from 0 to 1/2 of x times 2 times dx, plus the integral from 1/2 to 1 of x times 20 dx. And this is all over the integral from 0 to 1/2 of 2 dx, plus the integral from 1/2 to 1 of 20 dx. If you work out the arithmetic, which you can go ahead and do on your own, I've worked it out ahead of time, you get 31 over 44, which is approximately 3/4, but just a little bit less than 3/4, which is what we anticipated. I'm going to let you get a little bit of practice, and then we will explore the idea of center of mass even further.